Hello friends, in this channel you can find the electromagnetic lecture series, control system lecture series, signals and system series, aptitude lecture series and max lecture series, which they rich content. You can watch them uh, going to the playlist section of this channel. Okay. In this video we are going to see the question of screen gate EC 2019, which is from the communication systems. The question is probability of receiving X as -1 and 1 or 0.2 and 0.8 respectively. The input to the threshold detector is y equal to x plus n, where n is the noise added, which is uniformly distributed in -2 to 2. Y cap equal to -1 when y less than or equal to theta, otherwise 1, where y cap is the output of an optimum receiver, such that the probability of error is minimum. The minimum probability of error is, so we have to calculate the minimum probability of error. In this question, first we have the probability of receiving X. So we are transmitting -1 and 1. The probability of receiving X in the receiver side is 0.2 and 0.8. So we can consider this while transmitting X as -1, we are receiving 0, and X as 1, we are receiving 1. So the probability for 0 is 0.2 and the probability of receiving 1 is 0.8. The input to the threshold detector. So the signal is transmitted to the channel. It is receiving the noise from the channel. So it is added to the transmitter signal. We are receiving that in the receiver side is y equal to x plus n. After that, the distribution of the noise is given, and y cap is the output of the threshold detector, where y cap is the output of an optimum receiver. So please make a note of it, optimum receiver, such that the probability of error is minimum. The minimum probability of error is, for the optimum receiver, what is the minimum probability of error? So for the optimum receiver, we have the specific condition. We will see. Using that only we will solve to find the probability of error. Okay, first we can draw the density function, noise density function of the signal. Here that is given here, that is distributed, uniformly distributed. The noise added is uniformly distributed over -2 to 2. So here the density function, noise density function is here -2 to 2, uniformly distributed over. So uniformly distributed over, and then to make it there is the total as to 1, we are giving the amplitude as 1/4. So the total noise added value will become 1. Then we are going for the specific condition. If binary 1 is transmitted, that is when the x equal to plus 1 is transmitted, when the x equal to plus 1 is transmitted, what will be the output? That is input to the threshold detector, y of x plus 1. So we are the x value as 1, then for minimum value, adding this is minimum value, we will get -1, and maximum value, adding this noise maximum value, and we will get the 3. Then using this, we are drawing the probability density function when 1 is transmitted. The output probability density function when 1 is transmitted, that is using these limits -1 to 3, the amplitude is 1/4. Similarly, we are also calculating the threshold PDF value when 0 is transmitted. Using this, if binary 0 is transmitted, h equal to minus 1. This is given here, h equal to minus 1. Substituting that in the y capital H sub plus n equation, y minimum will become minus 1 minus 2 equal to minus 3, and y max equal to minus 1 plus 2, it is equal to 1. This is the PDF probability density function of when 0 is transmitted. Okay, minus 3 to 1, and the amplitude value is 1 by 4. We get the probability density function when binary 1 is transmitted here, and when binary 0 is transmitted here. And we know that the optimum receiver, the condition it should satisfy is the map criteria. The map criteria, optimum receiver using MAP, map criteria. Map criteria states that the multiplication of the PDF of 0 transmitter to the multiplication of probability of 0, and the multiplication of probability of 1 is transmitted, and the multiplication with the probability of 1 is equal. Here, when P of h equal to 0 is transmitted, the probability value is 2 by 10, that which is given here is 0.2, and we have written that as 2 by 10. Then we are considering also P of x equal to 1 is transmitted, the probability is 8 by 10. Using this value, we are drawing these two equations in the single diagram to calculate the optimum threshold value. So this is the equation for binary 0 is transmitted. This is first drawn here, fy of 0 into p of 0. Fy of 0 value is 1 by 4 into, and we know that p of 0 value is here 2 by 10. So the value become 2 by 4t. After that, we are, if 1 is transmitted, the diagram is here. That is fy of 1, the probability density function is fy of 1 equal to 1 by 4, that is multiplied by the p of 1 value, that the p of 1 value is 8 by 10, that become 8 by 40. So this higher value, this is the function of P of 1, probability density function when 1 is transmitted, and the probability of 1. So using this map criteria, when these two functions become equal, that point is called the threshold point. Here the minus 1 is the optimum threshold voltage or threshold value, that is minus 1. So to calculate the minimum probability of error, such that this is the optimal receiver value, then we have to find the minimum probability of error value. To find that, using these PDF functions, we can do that. We know that here below minus 1 there is no value, there is no value. So if we are transmitting so here 1 is transmitted. This is the probability 1 is transmitted to receive 0. This is the probability that when we are transmitting 1, we are receiving in the 0 value. So it is given here as the minus infinity to minus 1 f y of n, that the probability density function of 1. One transmitter given y dx equal to 0. There is no value here, so there is no possibility of making error when 1 is transmitted and we are getting in the receiving a 0 as when 1 is transmitted we are receiving as a 0. So there is no probability of error, that the value of p of 0 by 1 is 0. And if in the binary 0 is transmitted, then the threshold value higher than the threshold value, we have the values here. So this will become the error in the detector output. So we are calculating P of 1 of 0, that is 0 transmitter we are receiving as 1, that is the error value. So we are multiplying that Fy given 0 is transmitted, that value is 1 by 4 and the total value here is 2, then we are getting 1 by 2, that is P1 of 0 is equal to 1 by 2. Then the probability of error minimum value is given by probability of 0 into probability of 0 transmitted when 1 is received, and the probability of 1, and 1 is transmitted and 0 is received. The substituting these values, the probability of 0 is here 2 by 10, that is given in the question, 2 by 10 into 1 by 2 that we have calculated here, and this will become 0.1. Here the value of P of 0 transmitted 1 is 0, then the total value becomes 0. So the minimum probability of error you are getting here is 0.1. This is one of the interesting question. We have to know the optimum map criteria and the condition for the minimum probability of error, so we can solve it easily. Thank you for watching.